Hi everybody. In this video, we're going to be finally starting the very last part of Chapter 7 and the very last part of Trig. We're going to be ending Chapter 7, funnily enough, with Section 7.1, which is the first section in the textbook in that chapter. But the way things have been arranged, it's going to make perfect sense to end here. And this section is about inverse trig, and our focus is going to be solving equations similar to what we've been doing for the last several classes, using this idea of inverse trig, and you're going to see that some really important calculator skills also come into play. So we're going to look at solving an equation that has the exact same directions that you've been used to, which is solve this equation on the interval 0 to 2 pi. At this point, you're familiar with the fact that in an equation like 5 cosine theta minus 3 equals 0, the first thing you're going to want to do is isolate the cosine theta. When we isolate cosine theta, we get 3 over 5. And that's not one of the special trig values that we're used to seeing, like root 3 over 2 or 1/2 or root 2 over 2. And what that means is that the reference angle in this situation is something other than 30, 60, or 45, or in radians, pi over 3, pi over 6, or pi over 4. And that should make sense because, as you guys know, there's a lot more angles out there than just those three. So our focus in this chapter, or in this section, is going to be how do you find theta in a situation where that trig value isn't one of the special things that you know. And the answer to that question is using inverse trig and also your calculator. So in this situation where we don't recognize the trig value and we still need to figure out what angles have a cosine of 3/5, the way to do that is by using cosine inverse. The inverse trig functions are the functions that help us go from a trig value back to an angle. In other words, they undo cosine or undo sine. So when I write cosine inverse, it looks like cosine and then a little -1 like an exponent, but that means the inverse function. And what that does is it cancels out the cosine on the left side and leaves us with just a theta. And then to figure out what the cosine inverse of 3/5 is, or what the angle is, we need to go to our calculator. So on my calculator, I'm going to hit the trig button and I'm going to select cosine with a little -1, cosine inverse. And then I'm going to type in 3 over 5 and I'm going to hit enter. And what I find is that my answer is 0.927. And that's telling me 0.927 radians. And since we're used to thinking in radians in terms of fractions with pi, it's kind of hard to visualize where it's telling us that answer angle is. So for the purposes of the rest of this video, I'm actually going to switch to degrees because in decimals, it's a little bit easier to visualize where degrees are. So to switch to degrees, I'm going to click the little battery and go to document settings and change my angle from radians into degrees. I'm going to make that the default because I want to keep using it that way. And then I'm going to go up and copy my cosine inverse of 3/5, hit enter, and then get that value now in degrees. So that's telling me that the answer is 53.13 degrees. So now that I know that theta is 53.13 degrees, I also need to think about the fact that I might have more than one answer. So now that we're talking about, instead of 0 to 2 pi, for the purposes of today, we're talking about 0 to 360, we know that there are not one, but two places between 0 and 360 where cosine could be a positive value. So I've drawn a picture of 53.13 degrees, which is in the first quadrant. We know that cosine can be positive both in the first quadrant right here and also in the fourth quadrant right here. So what that tells me is that I need to consider a second answer to this equation. That second answer is going to be a fourth quadrant angle with 53.13 as the reference angle. To find that actual angle, I subtracted 53.13 from 360, the closest part of the x-axis, and got 306.87 degrees. Now I have my two answers on the interval 0 to 2 pi or 0 to 360. Now I'm going to look at a second example. This is, again, solve on the interval 0 to 2 pi, but we'll do it in degrees just to make things a little bit easier to visualize. The first thing I want to do in this equation is isolate the sine theta. When I do that, I'll see that sine theta is equal to -1/4. And as you now know, to find the angle, we can use inverse sine. I'm going to go over to my calculator to find that value. So on my calculator, I'll use my trig button to pick sine inverse, and I'll type in -1/4, and I'll get my answer of -14.48 degrees. Now, what you should notice about -14.48 degrees is that it is not between 0 and 360. So now what you should notice is that -14.48 degrees is not between 0 and 360, which means it's not a viable solution to this equation given our directions. What this means is that this is going to be a fourth quadrant angle whose sine is -1/4, but we're looking for angles between 0 and 360, and this just isn't one of them. Before we go any further, I need to talk a little bit about why, in this case, our calculator gave us a negative answer that falls outside of our solution interval, whereas in the first equation, the answer that our calculator got did fall within the solution interval, so we could use it and then find one more answer. The whole reason behind this lies in the way that inverse trig functions are defined. The rule is that all three inverse functions, sine inverse, cosine inverse, tangent inverse, which are also called arcsine, arccosine, and arctangent, those are just two different notations that mean the exact same thing. They are always going to, and I'm going to say this really carefully, they are going to output the angle that is closest to 0 in every situation. So here's what that means. So if you think about sine, we know that sine values are positive in the first and second quadrants and negative in the third and fourth quadrants. So what the mathematicians decided is that if you did sine inverse of a positive sine value, you would take the angle with a positive sign that's closest to 0. So that would be the angle in quadrant 1. So they got rid of quadrant 2 angles as possible answers. And similarly, they decided that if you were going to do sine inverse of a negative value, so you would need to get an angle out in either the third or the fourth quadrant, they decided they were going to again go with closest to 0. So they took out the third quadrant because the fourth quadrant is closest to that 0 marker on the positive x-axis. And because of that whole closest to 0 idea, we're not calling the fourth quadrant 270 to 360, we're calling it negative 90 to 0. So when you do sine inverse in your calculator, it's always going to give you basically like a positive or a negative reference angle, an angle that's between negative 90 and 0 if it's in the fourth quadrant, or 0 and 90 if it's in the second quadrant. Similar decisions were made for cosine inverse and tangent inverse. For cosine inverse, if you're doing cosine inverse of a positive, your calculator is going to give you a first quadrant value. If you're going to do cosine inverse of a negative, you're going to get a second quadrant value because cosine is negative in second and third, and second quadrant are going to give you numbers that are closer to 0 than they would in the third quadrant. So if you did cosine inverse of a negative, you might get something like 120 degrees. When you do tangent inverse, it's back to something that's very similar to sine. Tangent inverse of a positive will give you something in the first. Tangent inverse of a negative will give you something in the fourth. But again, to keep them close to 0, they're going to be written as like the negative reference angle. So you'd see something like negative 45 or positive 47 as your answers from tangent inverse. So this is all to explain why in this number 2 that I did, my calculator was giving me negative 14.48 as the answer because I was doing sine inverse of a negative, so it took a fourth quadrant reference angle for me. So what I know is that since my sine is negative in this equation, I'm going to be looking for 2 answers between 0 and 360, one in the third quadrant and one in the fourth quadrant, because we know from ASTC that that's where sine is negative. Then also, because we know that every single angle with a sine of negative 1/4 is going to have the same reference angle, we can see what our calculator really told us was that since there's a fourth quadrant angle of negative 14.48 degrees, whose sine is negative 1/4, that 14.48 is going to be the reference angle for the angle between 0 and 360 in both the third and the fourth quadrant that we're looking for our answer. And so I've illustrated this in the picture. What we need to do is find the actual measures between 0 and 360. And that's going to be pretty easy. If we remember that the negative side of the x-axis is 180 degrees, then we can see that that third quadrant angle is a little bit past that. So it would be 180 plus 14.48. So that would give us 194.48. And then if we look in the fourth quadrant, we can see that that fourth quadrant angle is a little bit lower than 360. So we can do 360 minus 14.48 to get our fourth quadrant answer. And that gives us 345.52. So we can write our final answers. So a couple of the most important things to remember about solving equations with inverse trig are that doing the inverse function on your calculator is always only going to output one answer. But we know that typically solving an equation between 0 and 360 should have 2 answers. And if we expanded the solution interval, we would get even more. The second thing to remember is that your inverse function on your calculator is always going to output the angle closest to 0, which is typically something you should think of more as a reference angle. So that's where you really want to rely on your diagram, like the one I have here, to help you see where your answer should be. You want to use your reference angle and what you know about quadrants to get your actual answers. As a follow-up to this assignment, you can think of it as a homework. I have 3 equations that I'm going to ask you to solve on the interval 0 to 360 using your calculator. And there's going to be a Google form attached to this assignment to submit your answers in. When you're doing these problems in your calculator, make sure you have switched it to degree mode in the way that I showed in this video, and you can go back to rewind if you need to. You'll know that you're getting the right types of answers if you're getting answers like 47 degrees rather than getting an answer like 0.46. That would be probably an answer in radians. It would need